Hey guys, my name is Doug Hunsaker, and we've got Sam Weiss as well on the line. Today we're going to be walking you through MachUp Plus and Pro, and this is for the DBF teams, the AIAA DBF competition. And we're really excited to be supporting this year and sponsoring it in a way. We just released MachUp earlier this year, this summer, and anyway, we want you to know that it's in progress. It's rapidly getting a lot better. We've done a lot of development, and we think that we've designed a really useful tool. And anyway, we're really excited to share it with you. And we hope that by giving it to you for free this year, that you'll give us some feedback and talk to us about what you like and what you don't like. And anyway, so we can continue to improve the tool. So anyway, we're excited to have you guys on board, and like I said, we're just going to walk you through some of that stuff today. Just so you know how this webinar is going to run, there's actually about a 30 to 60 second delay between when we're talking and when you guys are going to see this. And so anyway, just realize that. We've also you can actually ask questions throughout the webinar. At the top of your screen, you should see a 3x3 square. And if you click on that and then click on Q&A, then it'll open up a Q&A option on the right-hand side. And so you can ask questions. Obviously, because of the delay, it's going to take us a little bit to see those. And then we'll get back and respond to those as quickly as possible. So with that, I'll start walking you through MachUp Plus, and then Sam will give us an overview of MachUp Pro. Okay, before I get into MachUp Plus, I wanted to mention one other thing, and that's that we put together a DBF webpage that we think is going to be really helpful to you guys. And so it's just bluecraft.com/DBF. And you can see that we've got a bunch of downloads here. So we've got MachUp Pro for Windows and Mac you can download. We've also got a Python script that we're going to be going over more in detail. And then also an Airfoil database that you can download as well. And actually that Airfoil database doesn't have a whole lot in it. It's just something to get you started, to show you how things are formatted. And then you can add to your own database and you know, with your specific Airfoils that you're using. We've also got a how-to section that has a link to today's webinar. You can come back and watch that at any time. And then we've got a bunch of mock-up videos that just walk you through the MachUp Plus, the online version, and go into more details. So today we're going to be going over MachUp Plus, but really just pretty briefly. And then when you're ready, or when you'd like to know more about that, then you can go to that MachUp videos, and those are more detailed. We've also got a lot of helpful links on here. So for example, for Airfoil design, we've got Xfoil, Airfoil tools. Cloudfoil is a full CFD tool that we also offer that allows you to do full CFD analysis on an Airfoil through your browser. So we think that's pretty powerful and useful. And then we've also got a link to the UIUC database. Motor prop and battery design. These are three helpful tools that we've found. We've also got some links to the AIAA stuff. And then MachUp Pro is built to interface really well with Python and MATLAB. And so here we've got the Python homepage if you need to download Python to use it. We've also got the Spider IDE that is an interface for developing Python code. And then MATLAB, this is a MATLAB script that helps you read and write JSON files. We've got a list of teams here. These are the teams that are currently planning on using MachUp this year, and we expect that this list is going to grow as we continue to get the word out. And then further on down, we've got news feed. So this is a Twitter feed for DBF stuff, and then also some share buttons if you feel like sharing this information on a social network. So. Okay, so let us know if you have any questions about that, and I'm going to jump into an introduction to MachUp Plus. And like I said, there's there's more detailed information in the bluecraft.com/mockup/films. You can go through and find more information about this, but I'm just going to walk through real quick an overview of basic functionality of MachUp Plus. So, so here we've got a bunch of menus at the top, and the one we spend the most time in is add. Most likely in add, you can add wings, propellers, you can add 3D geometries. You can also add a bunch of lighting, and that helps for making really pretty pictures for presentations, things like that. You can also group objects together so they can move together. So that's kind of helpful as well. So I'm just going to add a wing here as an example. So here we've got our wing, and one thing to note is that the coordinate system for MachUp Plus is actually in a flight mechanics body fixed coordinate system. So that's a little bit different than most aerodynamic codes or tools, but it's really useful because so for example, we have X out the nose, Y is out the right wing, and then Z points down towards the ground. And it's a little bit different, I guess, for the aerodynamic side of things, but when you go to talk about forces and moments, it just helps a lot because everything now obeys the right hand rule. And so yawing and pitching moments are just more straightforward. Anyway, all of the coordinate system may be a little bit foreign at first, but you'll see that it's really useful in the end. Okay, so I've got this main wing and it's selected here. On the right hand side, we've got a component tree, and this lists all of the components in my design right now. So you see I added a wing 1, and when that's selected, then all of the properties here on the right hand side are referred to that wing 1. So we've got a name. Right now it's connected to my airplane, which is basically just the origin of our coordinate system. And then here's a bunch of geometry specifications. So I think you guys are probably pretty familiar with most of this stuff, but just for example, we'll put in 25 degrees of sweep here, so you can see that update on the screen. One thing that's important to note is that this main wing option up here, if you select that, then it uses the area of that wing to non-dimensionalize your parameters. So for example, lift coefficient, drag coefficient are going to include the area of this lifting surface when they're non-dimensionalizing. We can select a root airfoil and a tip airfoil, and it will linearly interpolate from the root to the tip, along that span. And so right now we've got it set up so that you can actually only have NACA airfoils in here for the graphics purposes. So if I put in like a NACA 0012, then I don't know if you were able to see that, but this root section now is a NACA 0012. And then we've got the aerodynamic properties of that airfoil that we fill in here. Now, like I said, this top section here where you have the name, that's only affecting the geometry. It's not affecting the aerodynamic coefficients. So for example, so you can put in any aerodynamic coefficients that you'd like here. So for example, if you're using the Clark Y airfoil, then you may use a NACA 2412 up here to represent the geometry of that, even though that's not exact. But then you can put in the aerodynamic properties of the Clark Y airfoil for all of the analysis that it's doing. It will be using those aerodynamic properties. So in MachUp Pro, you can put in the geometry and aerodynamic properties of any airfoil, but the Plus, the web version here, it only can handle NACA airfoils for the geometry portion. Okay, so we set a root and a tip airfoil. We can also include control surfaces. So if I say that this wing has a control surface, the first section here just defines the geometry of that control surface. And then we have mixing parameters where we can mix it with our elevator, rudder, aileron, or flaps. And this is useful. So once we get down here and specify the condition that we're operating at, let's say that right now we've mixed this control surface with the elevator, and I'm going to put in 10 degrees of elevator down here, and you can see that it now deflected that control surface with that elevator by 10 degrees. And we could actually mix that. Let's say that we want to mix it also with the aileron and give the aileron 5 degrees. And so now you can see that one side is deflected down at 15 degrees and the other side is deflected down at 5 degrees because it's mixing between the elevator and the aileron. So anyway, you can play around with that, and I think it's pretty straightforward. Okay, one thing that I'd like to point out here is, so I've selected this wing 1 right now, and I'm going to add another wing, and this second wing now it automatically calls it wing 2, and it automatically connected it to wing 1 because I had wing 1 selected when I added it. But I don't have to leave it connected to wing 1. If I'd like to, I can say that this is still connected to my airplane or the origin of this. And I'm going to move it back. You can see it copied some of the properties here into wing 2, for example, the sweep. And so I'm going to take off that sweep. And I'm also going to shorten that span down. And so you can see now we can build a horizontal stabilizer back here. And if I wanted to add a vertical stabilizer, I can add another wing, and I'll just put this one on the right-hand side and give it 90 degrees of dihedral. And let's also bring that down. So now I've got a vertical stabilizer as well, and I can add sweep and anything that I'd like to that. So anyway, that's how you can connect wings, or you can leave them unconnected and move them anywhere that you'd like. Okay, now I'm going to just real quick go over the analysis portion. So in the analysis tab down here, we can set the conditions. So we've got angle of attack of 1. You can also set a side slip angle. We give the control surfaces. We say what those are set to, and then we can run a bunch of different analyses on this airframe. So the most basic is forces and moments. If I click on update results, and this is, there we go. Took a little longer than I expected, but you can see it's given us the lift coefficient, drag, side force coefficient, and then these are the rolling, pitching, and yawing moment coefficients. And remember that these coefficients are all non-dimensionalized according to that, whichever surfaces I selected as surfaces that should be used. So for example, wing 1, we would want that checkbox there because we want to use the area of the main wing to non-dimensionalize those parameters. But wings 2 and wing 3, I probably don't want those included in the reference area of the aircraft. So I'm going to uncheck those and update results again. And you can see now it's saying we have a reference area of 8, longitudinal length of 1, and lateral length of 8. And it's slightly going to affect our coefficients because now we're using a different area that we're non-dimensionalizing by. So I'm not going to go into detail. We have videos that walk through these different things that you can run here, but these different analyses. But that should give you a basic overview of MachUp Plus. And the last thing now that I'd like to talk about is under the File menu. Once you have a model built, you can click on Export to MachUp Pro. And when you do, you click OK, and it will download this .json file. And I'm just going to open this .json file briefly so you can see kind of what it looks like. So now I should say that this feature is a feature that we're still working on, and so it's not polished yet, but it can be useful to start working in MachUp Pro. But you see, this is the file that it downloaded, and it's a .json file, like I said. And for those who are familiar with web development, you'll recognize the structure of a .json file. .json is kind of a newer data format that is quickly gaining popularity and is really widely used in web development. And it's also used or beginning to be used in the computational or an analysis field because it's just so easy to store data in very formatted ways. And so, for example, in MATLAB, you're probably familiar with structures or structs, and how useful those can be because you can basically define variables and you can store variables within variables and give them different properties and all types of things. Well, that's the same idea here. A JSON file starts with this curly bracket, and then everything inside of that curly bracket is like a struct. And so it's got a variable called tag, and inside of tag, it's got two variables. There's a UUID and a date. There's a license variable, there's a run variable, solver variable. So each of these main things out here is a variable, and then anytime you have a curly brackets, that starts the inside of that variable. And so inside of solver, for example, we have three variables that are defined as I'm showing here on the screen. So it helps you to structure this data and store it in a really useful way, and it's really powerful, as you'll see here in a second when Sam goes over MachUp Pro. So with that, I'll be watching for questions on MachUp Plus, and I will turn the time over to Sam to talk about MachUp Pro.
Excellent. Hey guys, Sam Weiss here. I'm going to start by, let me share my screen here. I'm going to start by going over in a much more detail the input file that Doug just showed you. Once we go over the input file, we'll look over running some of the commands, and we'll finish with looking how to interface MachUp Pro with Python and a simple wrapper script that I've written to show all the key features that you need to know to interface with MachUp Pro. So real quick, you'll notice here in my directory, I have the executable. My license file is in a bin file. Then I have the example.json. So this is similar to the file that Doug just exported from MachUp Plus. And then I have some data for the Airfoil we're using here, which is just a 0006. And it's just a profile because all of the Airfoil parameters are inside the definition file over here. So I'm going to go ahead and go through the input file, and feel free to ask questions as I go. I'm going to go into some detail, but a lot of this will seem very familiar after you have used the online version. So at the very top, the first variable is the Airfoil database, and it's just looking for a string here of the path to your Airfoil database. So currently, the only Airfoil data that I'm using is in my current directory, so I just have it pointed to my current directory. After that, we have the condition of the aircraft. We can put in the angle of attack, the side slip angle, the altitude above the ground, and that is actually just for analyzing ground effect. So when you want to look at ground effect, you can put an altitude there above the ground. Then you have some rotating rates, and that just defines the condition of your aircraft. After that, we have the controls. For this specific aircraft, we just have an elevator, but you can have any number of controls. The online version, you're limited to the 4 controls, the 4 basic controls, but here you can get as complex as you want. You can mix them however you want, and you can do some pretty amazing things with controls. For this simple example, we just have the elevator. You'll notice that you have a deflection in degrees right here, and then you have is it symmetric or asymmetric? In this case, it is symmetric because it's our elevator. So the right and the left-hand sides of the control surface will deflect in the same direction. For ailerons, you'd put a 0 there because they would be asymmetric. Under that, we have our license. Again, this is just a string that has the path to where your license is. Then we have the plane. Here we define the location of the center of gravity, remembering that we're using the body coordinate system. With X out the nose of the aircraft, Y out the right wing, and Z pointed down. So remembering that, you'll notice that the airplane we're working with right now is just a flying wing. And so I have a -1 to push that center of gravity back to where it can be stable. The name of the aircraft, you can name the aircraft whatever you'd like. Here we have the reference areas. And in the online version, it's calculating those based on what you specified to be a main wing or not. Here you can manually put them in to make them whatever what you want, so that you can compare things properly. We have a bunch of run commands. I'm going to skip this for right now because this is kind of the meat and potatoes here. I'm going to come back to this and go over that, but there's all the run commands. We have the solver. Here you have some relaxation factor, the convergence criteria, and the type of solver. So right now it's running a linear solver. If you want better results, you can put in the nonlinear solver and you'll get slightly better results. It also takes sometimes slightly longer. So for now, I'm going to leave it at linear. And here we get to the wing definition. Now again, this is very similar to what you see online. It's just in the .json format. So here we have the name. This is wing 1. The ID number. So every lifting surface needs an ID number. And then you have some information about where it's located and what it's connected to. So in this case, we're connected to 0. That means it's connected to the origin. And the root, the quarter chord of the root of the airfoil is deflected by nothing from that origin. So all these locations are based on the root quarter chord of your wing. We have the location you want to connect it to. This will make more sense later, but here it's just the root. And then the Y offset. As you adjust Y offset, it symmetrically separates the two lifting surfaces to either side of your plane of symmetry. Under that, for this lifting surface, we have the control definition. So these are the flap fractions here. They're both at 25% from the trailing edge. We have, it's sealed. You can leave that, it's a sealed flap. And then the mixing. So here again, it's just an elevator. But if you wanted, you could add, like Doug had, you could add your ailerons in here and have it mix so that when you deflect the ailerons, this control surface moves to some degree. Then we have the span and the root tip fractions. So this particular control surface starts at halfway through the span and ends at the tip of the airfoil. Then we have the dihedral, how many grid points there are, the mounting angle of this lifting surface, and then some airfoil data. Just like online, we have the name and then some linear properties here. And something to note here with this version, it's going to take this string here and go look for a file inside your airfoil database. And from that, it's going to pull all the information it needs. So in this specific case, it's looking in my current directory and it's looking for this profile, this underscore profile text file. And all this is the XY points to define that airfoil. And it's so that when you output the STL of your aircraft, it can plot it in 3 dimensions and you can see what the airplane looks like. So that's what that is there. And then we have the linear properties just like you had online. So this is the root airfoil definition. Then we have the root chord. We have whether you want it on the left side, the right side, or both. We have the span, the sweep in degrees, the tip airfoil, the tip chord, and then your washout. Remember that washout is negative twist. So 5 degrees of washout is wingtip twisted down -5 degrees. So that's the main wing or the center wing. And then we have on this particular aircraft some wingtips. And it's same stuff, but some important things to notice is we have ID 2. So make sure every one of your lifting surfaces has a unique ID number. And it's connected to 1, and it's connected to the tips, the wing tips of lifting surface 1. So just like on Doug's example, where the second airfoil was originally connected to the wing tips, this is connected to the tips. It's offsided by nothing, and there's no Y offset. Lots of dihedral, grid points, mounting angles, and all the rest of the data that we've already gone over. So that's that input file. Now here's some important things to remember. The first is dimensions. It's all non-dimensional. So if you are comfortable working in the metric system and you like to use meters and kilograms, you can do that. Just make sure you're completely consistent. So all of your lengths and distances need to be in meters. Everything needs to be in base units. Now, if you want to work with the standard system, you want to be in feet, then just do everything in feet. Make sure that you're when you're non-dimensionalizing things, you're using the correct air density with slugs per feet cubed. And as long as you're consistent, everything's going to work out just fine. So once you non-dimensionalize everything. So let's look at the run functions real quick. These are the same functions you'll see online exactly. The only different one is you have an option to output an STL file, and that's just so you can look at your model. So they all have variables inside them that are run, and if it's a 0, it doesn't run. If it's a 1, it does run. So for now, I'm going to just turn them all on. The aerodynamic center finds the location of the aerodynamic center of your aircraft. This is really useful because it's kind of a complex thing to find in a lot of aircraft design, but here it just takes care of it for you and finds it. We have the derivatives, and this just outputs the derivatives of your aircraft per lifting surface. Distributions gives you all the information about all the lifting surfaces and the lift coefficient at each section and the moment coefficient of each section. We'll look at that one. Forces, and then pitch trim. And I wanted to spend some time here. In pitch trim, you can specify a lift coefficient and a moment coefficient, which control surface you want it to deflect to balance out your moment. And then you can have some convergence criteria, a relaxation factor, and a step, and then the one to run. So when you actually start to analyze your aircraft and you want to look at what it looks like at a cruise condition, what you need to do is define a lift coefficient that's non-dimensionalized with your air density, your airspeed, your wing area, and you non-dimensionalize your weight by all those things, put in that lift coefficient, and then it will trim at that condition. So here we'll leave it at 0.6 and 0. So we're going to trim for a cruise condition. I'm going to come over here to my terminal. I've already added to my directory, which is down here. And to run it, all we're going to do is execute the file, MachUp Pro, and put in a space and then our definition file. And I'm going to hit return. And there, when it just ran all of those functions at once, let me pull this out so we can look at it a little bit better. So from the top, here we are. It just started running there. It read in all my airfoil data. It located the aerodynamic center and it wrote it to the screen here where that exists and the moment about the aerodynamic center of the aircraft. And it also outputted here a .json file that it makes it easy for you to interface with Python or MATLAB, and it gives you that information there. Then it ran the derivatives. It wrote all the derivatives to the screen here, and again, outputted them to this file here so you can interface with it. It ran the distribution command, output some of that information to the screen. You can see the inviscid, the viscous, and the total results. And again, if you go down here to the distributions, it's this text file that has all this information. It's really easy to parse and lets you get the distributions of lift and moments and drag on all your lifting surfaces. I have found this file to be really useful in my structural design of my aircraft, where I can get the lift distributions and size my structural components properly for those lifting loads. After that, we run the forces. Again, it gives you some outputs, and down here we have the JSON file. Same thing, really easy to interface with Python or MATLAB, and we're actually going to interface with that forces file. And then here it did the pitch trim. You can see it has our desired, or here we go. Here we have it converged to our desired coefficient of lift and our coefficient of moment to 0. And it outputted that at an angle of attack of 5 degrees and the elevator at 13 degrees, we trimmed this aircraft. And then finally, it ran the STL. So let's go ahead and take a look. Here you can see the .stl. You can download a viewer for STL, but it's also really easy if you just take it and drop it into MachUp. And there, that's the aircraft that we're working with right now. Just a simple little flying wing. And so I'll often be changing things in my MachUp Pro definition file and then just drop it into MachUp to make sure it looks the way that I want it to look. Yeah, so I think that's all the output files. Something to consider is in further videos, we'll have we'll explain how to do some more complex geometry. You can have specific input files that do chord distributions or twist distributions on your aircraft, and you can make some pretty good looking aircraft. And the one on our website right now is this guy. And this was made, obviously it's not, just by defining, a span and a chord and a root and a tip. It's by a distribution file that gives you the chord distributions for every lifting surface. And you can make very smooth transitions just like they look in real life. And this is the exact model that MachUp will analyze with all the curves. So it can be really helpful and really powerful. And we'll have some more videos on how to do that later. All right, so that's kind of the summation of the input file. I'm going to go ahead and turn all these things off, and now I'm going to show you how to interface with with Python. In this case, I'm going to be using Python, but MATLAB will be just as easy. So here's the script. This script is written to do some sort of sweep. Right now, it's set up to do an angle of attack sweep, but you can set it up to do any sort of sweep you wanted. So I'm going to start in the middle of the loop and explain kind of what's going on here. First, we're just opening up our JSON file and reading in that JSON file to this variable, aircraft data. Once we have that in, we close the file, and I can access aircraft data is a library now, or a dictionary, I should say. It's a dictionary within Python, and I can access all the variables within with brackets and strings. So here is the input file. Notice that we have conditions variable, and then underneath conditions we have alpha. So same thing here. We have conditions, alpha, and then we can set that variable to whatever we want. So we read it in, we change the variable to what we want, we rewrite the file, and then we run the program, just like the command we put into the command line. We run the program, and then we read the forces file here, and we dump all that data into aircraft forces. We get out the data we want. In this case, it's the lift, the moment, and the drag coefficients. And then we save those into some data structures here. And obviously, this is in a loop that's going from -10 to 15. And then at the very end here, we plot the results so we can take a look at it. So I guess here at the top, I'll mention that the Python JSON library is very useful. And it's the one that makes interfacing with MachUp so easy. Then you have the OS, which allows us to do the system commands. And then matplotlib is a really useful library that lets you do plotting as easy as you may know how to do in MATLAB already. So I'm going to go ahead and run this. And we can see here on the right-hand side, it's running a bunch of times. And it's done. And let's go look at, here's the data that we just plotted. So alpha varied from -10 up to, I guess, 15 here. And you can see the lift coefficient changed with alpha, the moment coefficient, and the drag coefficient. So they're all there. And you can very easily change this to sweep whatever is interesting for you. So for example, we could sweep through the center of gravity and then trim each time and make sure that we know our CG limits forward and aft so we don't locate our CG in the wrong spot. So that's, I guess, the summary of how to connect Python with MachUp Plus. All the key components are in this file, and you can download it, as Doug said, online. And all the key components are here so that you can write any sort of wrapper you want to design your aircraft. I have found it really useful in optimizing. I can run a bunch of sweeps and see how variables affect one another, and then set things the way I want them so that the aircraft is optimized for my mission. So that's all I have. I'll turn the time back over to Doug.
Okay, so there were just a couple things that I thought of while you were talking that I think we need to mention. So first of all, license files. So every team will need a license file to run MachUp Pro, and I'll be emailing those out this afternoon. So you can download MachUp Pro from the DBF webpage, and then but to run the license file, you'll need to, to run MachUp Pro, you'll need a license file, and I'll be sending that out. And then the other thing that I wanted to mention is just how to treat a fuselage. I read through the DBF competition for this year, and it's a very interesting competition. And anyway, it looks really cool. You're going to want to be able to model, though, the drag from a fuselage that you have in there. And so I should say, with any of these codes, if you use AVL or ASWing or VL Arrow, I mean, there's a lot of different codes that people have developed for aircraft design. And modeling a fuselage is probably the most difficult thing in any of these codes. It's a really challenging problem. And so the way that we've found that works best, at least in MachUp for the time being, until we can come up with a better way, which we have on our radar, and we're hoping to have a better way in the future. But for right now, the best way we've found to handle it is to put in a lifting surface, to put in a vertical and a horizontal lifting surface in that region of the fuselage, and then give it a lift slope of 0, but then give it a parasitic drag coefficient, or a CD naught, and then it will incorporate that drag from the fuselage, but it won't treat it as a lifting surface. You won't get any lift off of that fuselage. So that's one way to handle it. There are also other empirical methods that you can use to model the fuselage, but for right now, that'd probably be the way that I'd approach it. So, okay, I haven't seen any questions pop up. So anyway, feel free to email us with questions. You guys have our contact info. And again, we're really excited to work with you, and hope that we can have conversations. Please don't hesitate to email us if there's anything we can do to help you out. And like Sam mentioned, we'll also be putting together future webinars that go into more detail, so you can get really defined geometries and more complicated geometries. Right now, what we went over today basically allows you to do linear geometries. MachUp Pro can do much more complicated geometries, and we'll be going over that in more detail later. So with that, thanks for listening, and we'll be in contact.
See ya.